Okay, 8.6, common and natural logarithms. This is probably, if you understood 8.5 and got 8.5 down really well, this will be the easiest section in the entire book. Because the homework problems on this are just like the homework problems in the previous section, or at least it's like some of them, except there might be some application problems, but they're really just application problems where they give you the formula. So, you just plug numbers in, so it's not too bad at all. But you need to know your properties of logarithms. So first, a common logarithm. Common logarithm is a logarithm base 10. Okay? And log base 10, we usually don't write the 10. That's how common it is. It's kind of like square root. You don't write the index 2 usually. Why? Because square root is actually the most common radical, right? It's the most common, it's more common than a cube root, a fourth root, fifth root. And it was also the first that was invented, was the square root. Same thing here. Log base 10 was the first one that was invented, and it was actually invented to multiply large numbers by adding things using that product rule of logarithms. That's what it was actually designed for. Of course, now we don't use it for that so much, but it turned out to be very, very useful for a lot of things. The guy that invented it was a guy named Napier, the Scottish guy, kind of like a French name that's been mispronounced, like Napier, but it's Napier. Yeah, I think it's Napier. Anyway, you don't have to memorize that part. Okay, so this is important because this is on your calculator. Okay, it's the most common logarithm, so which one would you put on your calculator if you were designing it? Probably the most common logarithm, which is called the common logarithm. So if they say common logarithm, they mean base 10. And if they don't write a base at all, they don't mean base 1. There's no base 1. Okay, they mean base 10. All right? So this is often used with scientific notation. In fact, that's the most common use for this, is with scientific notation. Because because log of 10 to some power is just the power. So it's a way to kind of keep track of the exponents of 10. In scientific notation, remember, you have a number between 1 and 10, less than 10, strictly less than 10, so up to like 9 point something, times 10 to some power. So if you take the log of that, you get the log of the number between 0 and 10 plus the exponent. So it's going to be approximately the exponent. Okay, a little bit more than the exponent. So if the exponent's like 5, it's going to be 5 point something. So say you had 3 times 10 to the 25th, and you took log base 10 of it, you'd get, what did I say, 10 to the 25th? You'd get 25 point something. You see how that works? So scientific notation and base 10 go together really, really well. So they use it a lot in astronomy. They use it a lot in things, really small numbers like biology. What's the size of this telomere or whatever they're talking about? And they'll measure it's really small. What's the size of this atom in physics, right? Very small. How many atoms are there in this case? Very large number. So very small numbers, very large numbers tend to use scientific notation, and they tend to use log base 10. Now, anytime you're going to use calculus, which you were not using this class, but calculus has to do with studying what happens when things change. Like things are changing over time. Like maybe you're applying a force to some object, but that force is changing over time. Like a rocket works this way. The weight of the rocket changes as it goes up because it's burning fuel, so it becomes lighter and lighter. To figure out what your acceleration is going to be after a certain amount of time of burning this fuel and stuff, you need to use something called calculus, okay? And the natural logarithm is the one that naturally works best with calculus. And calculus is like arguably the most important field of mathematics. It's been used a lot, especially in physics, in the sciences. Other than statistics is also used a lot too. Although, yeah, statistics and calculus. So you use this natural log a lot. It's log base e. That's the same e that we had when we did continuously compounded interest. That same e, 2.7 something something, 72 something something, I think. Anyway, so we don't usually write it as log base e though, because this also happens a lot. This is actually used in many areas of science far more than a common logarithm is. Just because the computations come out really nice with this base for various reasons that would be very obscure to you probably, unless you've had any calculus. So log base e, we usually write that's a ln, and usually when I handwrite it, I write it in cursive, ln, because otherwise it kind of looks like one n, which is not. That's a l. All right, and so if you look on your calculator, you'll see you have an ln button, and it's probably the same button as the e button, because the exponential function base e and the logarithm base e are inverse functions, so they're on the same key. You'll also notice 10 to the x, the key that has the 10 to the x key will also have the log key, because log of x, right, log base 10 and exponential function base 10 are inverse functions. So they kind of remind you of that by sticking them on the same key. Right? So I mentioned this. I wrote this out so you have it for reference later on your PDFs. So I write it like that. In print, you'll always see it printed with an L. It's a little L. They never use a capital L there, which seems like it would be reasonable, right? But that's just because they're saving space. Little L doesn't use as much space. But it doesn't look like a printed one. A printed one usually has the little hook on top and little bar under it. Okay, so I'm just repeating what I said, used a lot. So it might sound like I'm spending a lot of time on this little bit of stuff here, but hey, guess what? This is the only page for this section, so don't worry about it. So this is used a lot in calculus because computations are easier, and if you take calculus, you'll see it's way easier with base e than it is any other base in the logarithms. In fact, we often, if it's some other base, we switch to base e using the change of base formula that was on the previous page. Or we just never use the base 10 or base 5 or base 4 at all. Base 2, base 8, things like that are used a lot in computer science, by the way, because it's a binary system. Okay, so no, the N and ln, that's the guy Napier. But a lot of people think of it as natural, so natural log, but if you think of something like French, they write the adjective after the noun. So logarithm natural, or logarithm naturel. But that's not what it stands for, actually. It doesn't actually stand for natural. It stands for the guy's name who invented logarithms, just to honor him. He didn't invent this one. It's just to honor him. So it's Napier. That's written in International Phonetic Alphabet, which is language is kind of a hobby of mine. So I'm terrible at them. That's probably why. But anyway, that says Napier. Okay. That's it. So the problems in this section will be just like the problems in the previous section, Plus, maybe they'll have applications where they give you the formula. Because why would they have applications in this section? Because these two are used in a lot of applications, whereas other bases are not used very often in applications.